Pascal's principle is a principle used in Pascal's principle has many applications. The principle says that a change in the pressure at one point in a fluid will equal the change in pressure at any other point in the fluid. If you take a look at this hydraulic system, a force is being applied through an input piston. That's simply a surface in contact with a fluid. There's an output piston which feels an output force from the fluid. Now it says when no forces are being applied, assume the liquid in the container is approximately at atmospheric pressure at the top of the fluid. Assume the weight of the pistons themselves are negligible, and you're going to apply an 80 Newton force to the input piston whose radius is 0.1 meters. What will be the pressure increase in the fluid due to the presence of the implied force? For that, we're going to want to use the formula pressure equals force divided by area. It should be noted that there's an atmospheric pressure that would be present at the surface of the fluid if the person wasn't pushing on it. So instead of using P equals F over A, I'm going to change it to delta P equals delta F over A. So I'm going to change the formula to delta P equals delta F over A. Now when the person isn't pushing, there's no force. Since the person pushes with 80 newtons, that's going to be the delta F. The area of this piston is going to be, according to the area of a circular formula, pi times 0.1 meters squared, pi r squared. The change in pressure is 2,546 pascals. So what pressure will be transmitted to the output piston? The same. 2,000. So what pressure will be transmitted to the output piston? The same, according to Pascal's principle. Now, what will be the effect of this? Notice that the output piston has a much larger radius than the input piston. And remember that pressure is due to collisions between particles and a surface. So when all these collisions occur, the output piston is going to feel a force. But which piston feels the greater force? The one with the small area or the one with the big area? Well, all we have to do is use the formula one more time, but this time is for the output piston, not the input. But you use the same pressure. we're going to solve for the force at the output piston. Okay, solve that equation. $18,000 newtons. So 80 newtons in, 18,000 newtons out. All due to Pascal's principle.